The last statistical display that we are going to look at is box plots. So box plots use a number line to show the distribution of a data set by using the median, the quartiles, so your Q1, your Q3, and extreme values. Okay, and essentially what a box plot is doing is it's splitting it into 4 equal parts. That's why we're using those quartiles. So first, let's just look at constructing a box plot. So listed below are the lengths of the winning distances in women's Olympic shot put event. So we've got our numbers. First thing I need to do if I need my median, etc., is to put it in order from least to greatest. So I've got 65, 67, 67, 68, 68, 68, 72, 74. Now that we've got our numbers in order, I can go ahead and find that median. So I'm crossing off lowest, highest, lowest, highest, lowest, highest. If I crossed off 68, I'd also have to cross off here. So both of these are in the middle. If they're both 68, that tells me right away that median is 68. And I'm going to draw a line in between those two. Now, when I'm finding my Q1, I'm finding the Q1 of this lower half. So lowest, highest. If I crossed off here, I'd have to cross off here. So I'm left with both of these. They are both the same though. So 67 and 67 is going to give me a Q1 of 67. Same thing for the top half. Cross off lowest, highest. I have these two in the middle. They aren't the same, so I'm going to add those two together and divide by 2. And when I do that, I get 70. So we had our Q1 was 67, our median was 68, our Q3 was 70. Okay, and I'm gonna kind of put dividers where those were. For our lower extreme, that is just the lowest value. So the lowest value we have here is 65. Our highest value for our upper extreme is 74. Now for plotting, I'm going to plot these points. So this is different than when we did comparing rational numbers and we plotted for inequalities. We are actually gonna put the dot above the line. So at 65, I'm finding 65. I'm leaving a little gap and putting a dot above it there. 67 is my next one. I'm going to put a dot above that. 68 is after that, so putting a dot above there. 70, putting a dot above, and 74, putting a dot above. So I'm trying to keep them lined up above the line there. Now when I'm creating my box plot, it should have a box in the middle and lines going out. So the second and the third dot here are going to be the sides of my box. So I'm going to draw a vertical line through and I'm going to connect those. So I've made a box and I still have these dots on the outside. The dot that's on the inside of my box, I'm going to draw a vertical line through. And then I'm going to connect this lowest dot with a horizontal line connecting to the box. And I'm connecting this upper dot with a horizontal line going that way. So we have a box in the middle, and sometimes people refer to it as whiskers. So what this plot is really showing us is that this portion right here is kind of representing these two numbers. This next portion right here is representing these two numbers. The next portion right here is representing these two numbers. And this next portion here is representing those two numbers. So it's splitting it into 4 equal parts. Even though each of these is different, this one is really small. Right here, you only have a difference of 2. Here we have a difference of 1. Here a difference of 2. Here a difference of 4. So even though each of these sections represents 2 numbers, 2 numbers, 2 numbers, 2 numbers, some of them are more spread out. Here, the difference between 70 and 74 is much bigger than the distance between 67 and 68, which is represented there. So let's look at this again and use it to answer some questions. So a restaurant recently collected data to see how many minutes their guests waited for a table. The data is presented in the box below. Use the plot to answer the following questions. So it's already plotted for us. We don't have to make the box plot. I'm going to list out these numbers. So I like to write, this is my lower extreme, this is my Q1, this is my median, Q3, upper extreme. So my lower extreme is right here, which falls at 15. So my lower extreme is 15. My Q1 falls at 24. My median right in the middle of the box is at in between 28 and 30, so that's at 29. My Q3 is right here in between 32 and 34, so that's at 33. And my upper extreme is between 34 and 36, so that's at 35. Now we're going to answer some questions about this. So first we're talking about the ranges. Where is it the most clustered? So keyword there is clustered. I'm going to kind of mark it off into these 4 different sections just like I did up here. So we have our first section here, which is the lower extreme to the Q1. We have our second section here that I highlighted in blue, which is the Q1 to the median. We have our third section here, which is highlighted in green, which is the median to the Q3. And our last section here, which I highlighted in yellow, is the Q3 to the upper extreme. So clustered, I remember the word CL, clustered means close. That's how I remember. So the closest together. You might be able to look at this and see right away that it looks like this stretch is the smallest. It is the closest together. But if not, you can count the distance. From 33 to 35 is 2. Here, from 29 to 33, we're going over 1, 2, 3, 4. This is a distance of 4. From here, we're going over 1, 2, 3, 4, 5. And here, from 15 to 24, we're going over 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can either count or I can subtract. 24 minus 15 is 9. 29 minus 24 is 5. 33 minus 29 is 4. 35 minus 33 is 2. So the most clustered, the closest is going to be the smallest of these, which is right here. I'm not writing 2, I'm writing what is the range. It's from our Q3 to that upper extreme. Now doing the same thing, except the question is asking where is it the most spread out. So again, this might be obvious if you just look at it because you can see that this pink portion looks like it is the most spread out compared to the others. Plus, as we look at the numbers, 9 is bigger than any of those other spreads. So what is the range? It's from that lower extreme to the Q1. What is the IQR? We're just doing our Q3 minus our Q1. We already have those numbers here. So I'm taking my Q3 of 33, subtracting my Q1 of 24, and I get that my IQR is 9. And then the range, we're just taking our highest number, which is our upper extreme of 35, minus our lowest number, which is our lower extreme of 15, is equal to 20. Okay, let's try that again. The number of goals scored by Blackhawks players in the 2012-2013 season is shown in the box plot below. So I like to list out lower extreme, Q1, median, Q3, upper extreme, and then list those numbers. This is at 3, 6, 8, 14, 23. And then I'm going to highlight those ranges just like I did on the last one. My lower extreme to Q1 in pink. My Q1 to median in blue. My median to Q3 in green. My Q3 to upper extreme in yellow. And we are going to be looking for where it is the most clustered and where it is the most spread out. Again, you might be able to just look at it and tell, but if not, we can calculate the distance between. From 3 to 6, that is a distance of 3. From 6 to 8 is 2. Again, either counting 1, 2, or subtracting 8 minus 6. From 8 to 14, I'm either subtracting 14 minus 8 or I'm counting 1, 2, 3, 4, 5, 6. And then our last one, Q3 to upper extreme, I'm either subtracting these or I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9. So where is it the most clustered, or CL for close? My smallest range is this blue one right here. It's a distance of 2, and that's from my Q1 to the median. So Q1 to median. Where is it the most spread out? Pretty obvious right here. This stretch in the yellow, that stretch of 9, is our Q3 to our upper extreme. What is the IQR? I'm taking those values, my Q3 of 14 minus my Q1 of 6. I plug that into the calculator and I get an IQR of 8. And then what is the range of the data? Taking my highest value, my upper extreme of 23, minus my lowest value, my lower extreme of 3, gives me a range of 20. All right, again, let's do it. I'm gonna list out lower extreme, Q1, median, Q3, upper extreme. So my lower extreme is at 10, Q1 is at 15, median is at 21, Q3 is at 25, upper extreme is at 35. To answer these questions, I'm going to highlight my ranges again. So my lower extreme to my Q1, my Q1 to the median, my median to the Q3, my Q3 to the upper extreme. So again, we're looking for the two parts, where it's the most clustered, where it's the most spread out. Maybe you can tell by looking at it, some of these are a little bit closer looking though, so I'm going to double check. From 10 to 15, that is a range of 5. From 15 to 21, that is 6. 21 to 25 is 4. 25 to 35 is 10. So clustered CL is the closest. 5, 6, 4, 10. 4 is the closest. That's from our median to the Q3. Where is it the most spread out? Again, we can kind of see that big stretch right there in yellow, which is our Q3 to our upper extreme. IQR, we're taking our Q3 of 25 minus our Q1 of 15, which gives us an IQR of 10. What is the range? Taking our highest value, that upper extreme of 35, minus our lowest value of 10, which gives us a range of 25.